अच्छा winter 18-1, so this is 2-1. इसमें organic questions, and there are hardly any organic questions. 1 second. So starting over, not this one, starting over here. That's greenhouse effect. This one has something to do with this question over here has something to do with CFCs. So I'm going to do this one first. So CFCs give the meaning of the term enhanced greenhouse effect. That is basically heating of the atmosphere. Okay, that's basically greenhouse effect. Explain how CH-ClF2 may contribute to this, because it destroys ozone. And the reflective cover, okay? Ozone helps reflect. So ozone in the upper atmosphere, it basically like the okay? Ozone in the upper atmosphere helps to reflect the powerful harmful UV rays. Suggest one other environmental problem associated with the use of CHCl2F2. So just a second, okay? Let me just quickly have a look at the marking scheme as well for this particular question. They're kind of asking the same thing. Again, just 1 second. So I think this is the PDF. As a greenhouse effect. So that is the question on acid rain. 1 second. So one was traps more heat. So greenhouse effect was traps more heat, which leads to global warming. I mean, I think we did not write traps more heat. Ozone depletion, that's fine. And CC part 1 addition, what does that mean? Just a second. CC, neither B. Just 1 second. Ozone depletion, that's 1 mark. B2 is traps more heat. So basically it was overlapping. The only confusion was sometimes the questions are very overlapping and they're very general, so you can't really figure out what they're asking for, what they're looking for. So the first part was global warming, that creates human activity. Well, it's a very general question. Give the meaning of the term enhanced greenhouse effect, and they just wrote this thing that it creates or increases the greenhouse gases. That's about it. Agle part where they were asking for how does this do that? So they wrote it traps more heat and creates global warming. And the part 3 was it leads to ozone depletion. So kind of questions, it was very general. Let's move to the next one. The organic part, CHCl2F2 is also used to produce the monomer C2F4. This monomer can be used to produce PTFE. State the type of polymerization that occurs during the production of PTFE. So that is addition polymerization, because it's an alkene and they're asking you to, so this is C2F4. They're asking you to draw the repeat unit. So it's going to have fluorines, 4 of them, C2F4. And it will bond with other monomers, which would be exactly the same. The double bond between them is going to go away. So the double bond would go away, and it would be replaced by a single bond, and they would link up. So you have to draw just one repeat unit. So you're just going to draw this and write N. And they are also asking why it's used for cooking, because so why is it used for cooking? It's used as it's 1 mark. It's used as a non-stick. It's non-polar. So things don't get attracted to it. Plus it's heat resistant as well. Why? Because the CF bond is very strong. Small atoms, they always make strong bonds. So again, I'm going to refer to the answer in the marking scheme as well. Why it's used in cooking. Part 3, just a second. This was part 3 addition. We did all of that. I said their answer for that it was unreactive. I said it was non-polar. So it's kind of the same thing. Unreactive or inert. So both of my statements kind of point to that fact that it's non-polar and the CF bond is very strong. So that would make it inert as well. So I guess they were looking for, maybe they'll probably accept that. This is kind of a more detailed answer for the same thing. As the next one is waste disposal can cause litter problems, suggest 2 other difficulties associated with the disposable. So it's obviously non-biodegradable. Remember this, all addition polymers are non-biodegradable because this carbon chain is very, very stable. It's harder to break. So they're all non-biodegradable or 2 other, so burning it would obviously produce harmful gases. The next organic project there. The problem with these questions, I'll just give you a general guideline that questions, especially like this, I mean, the question is a very general question. It's a very open-ended question. Like, why is it used for cooking? So there's, I mean, you could give 1,000 reasons why it's a good coating for cooking pans. So remember, even the marking scheme, don't rely too much on the marking scheme because the marking scheme is just a broad guideline. Open-ended questions have many, many acceptable answers as long as they make some sense. So this one is an open-ended question. This was also kind of an open-ended question, like how this would, so it's, I mean, their simple answer was that it traps heat and it causes global warming. But you could have gone into a lot more detail. You could have talked about that it's destroying ozone and the harmful UV rays are entering the Earth's atmosphere, and which is heating it up. So ये सारा clear अभी तक? Siddha, Raid, Osma, Mahad, is this clear? So the next one, the organic question, you've got to complete a table to show. So this one is not an open-ended question. It's a very specific, it requires a very specific answer. Now complete the table to show what you would observe when an aqueous solution of glycolic acid is added to, this is glycolic acid, is added to all of these. So sodium carbonate, now it's a carbonate, it's a carboxylic acid. So it's obviously going to react. Observation means what would you see? So when you have a carbonate reacting with it, whenever you have a carboxylic acid, it reacts with a carbonate. A salt would be produced in carbon dioxide, so it's going to produce RCO -1, Na+1. I mean, this H would get replaced, Na+1 and H2 and CO2. So the observation would be that CO2 would produce effervescence. Bubbles. Does the reaction occur? Obviously, it does occur. What's the functional group that's reacting? It's the carboxylic acid functional group. The next part is 2,4-DNPH. Nothing happens with 2,4-DNPH because 2,4-DNPH is used where? It's used as a test for aldehyde and ketones. That's what 2,4-DNPH is used for. You get an orange press red. This one is not an aldehyde. It's also not a ketone. This one is a carboxylic acid, plus it's an alcohol. So nothing happens. And then dichromate 6, what happens to it? Dichromate 6, what that would do is, if it's a primary alcohol, it will turn it into an aldehyde, and that aldehyde will get converted to a carboxylic acid. So this OH over here is a primary alcohol. So this OH will turn into a carboxylic acid. So this one will turn into a, and the other one will also turn into a I mean, the other one was already a carboxylic acid. So what is the observation? Dichromate 6. यहाँ पे लिखा भी होगा dichromate 6. I mean, not written, but the color change is going to be orange to green. There's going to be a reaction, and the functional group that reacts with it is a primary alcohol. I mean, write the whole thing, primary alcohol. That is the part that's going to react with it. As I said, next one is two reaction sequences to make glycolic acid are shown. The pehla jo hai, that's an aldehyde, HCHO. So this is an aldehyde. What happens to an aldehyde when HCN and NaCN are reacted with it? You get nucleophilic addition. I mean, this is the reaction that happens when aldehyde and ketones react with it. The carbon, the alpha carbon, the aldehyde or ketone carbon will turn into an OH and CN. OH and CN will get added to it. So, either क्या होना चाहिए? X would be कि the double bond OH and CN will get added to it. So usko add kar do. There's going to be an OH, and at the bottom there's going to be a CN. And in the next step, the OH is still there, but the CN has turned into a carboxylic acid. So this is this part. How does a nitrile turn into a carboxylic acid? CN. It turns into a carboxylic acid. You heat it with dilute acid and reflux. That's how you do it. So यहाँ पे there's going to be dilute H2SO4. Plus reflux. And the next part is sequence B. There's a carboxylic acid. It reacts with bromine, and the bromine gets substituted into the carbon chain. So how does a bromine get substituted into the carbon chain? That is free radical substitution of alkanes. What happens is, it could happen with any alkyl chain, any carbon chain. UV light or bromine, and the hydrogens are going to get substituted in the carbon chain with bromine. So this definitely requires UV light. And in the next step, the halogen is replaced by OH. PR gets replaced by OH. So how does a halogenoalkane turns into an alcohol? The halogenoalkane undergoes nucleophilic substitution with OH. The Br or whatever the halogen is, it's going to get substituted by the OH, and it will turn into an alcohol. So यहाँ पे ना the Br is replaced by an OH. So this one is definitely NOH aqueous and reflux. Plus reflux. And draw the structure of पता नहीं X का क्या है, तो X तो हमने पहले draw कर लिया था. That's CHH. I mean, so we've kind of answered the whole question now. So name the reagent for reaction 2. Name the mechanism of reaction 3. Reaction 3 is free radical substitution. This one, free radical substitution. This reaction number 1 was nucleophilic addition. The aldehyde ketone one, this one, HCN and NaCN, that's nucleophilic addition. And then you have reaction number 4, that is hydrolysis, nitriles turning into carboxylic acid. That one is hydrolysis. So state that we kind of did all of that. फिर वो reaction number 4 की बात कर रहा है. He's saying that it occurs by an SN2 mechanism. Complete the diagram. For the mechanism for reaction number 4, include all relevant. So what happened in this case? The Br, the carbon had a positive charge. The OH was a nucleophile, and it will attack it, and the Br electrons would get repelled. That's about it. So they were just looking for and the Br was slight negative. So that's kind of about it. Iska jo actual mechanism, that's this one. It's It's where's the OH comes in, the halogen gets knocked out. Primary halogenoalkane case में. Tertiary halogenoalkanes, the Cl leaves first, फिर जगह बनती है because it's surrounded by large groups. The OH minus 1 then comes in. So उसके बाद glycolic acid can also be made by reacting glycolic acid with NaBH4. State the role of NaBH4. So this one is an aldehyde. ठीक है, it's an aldehyde because it's serial bond over NH. तो क्या रोल होता है उसका NaBH4 का? Aldehydes, this one over here, they turn back into alcohols. वापस alcohol बन जाते हैं. तो state the role, it's a reducing agent. And write an equation for this reduction using the molecular formula, use H to represent NaBH4. So we're going to write this equation. It's going to be CHO. The other side is COOH, COOH. And it's undergoing reduction. So NaBH4 is saying that use it as H. आगे product क्या बन रहा है? The product is this one. It's CH2OH. And the other side is COOH. So water बीच में ना add कर देना as per requirement. So you've got 3 oxygens over here. You still have 3 oxygens. That's fine. You got so what exactly happened? I think 2 hydrogens got added. That's it. So you just make 2H. That's it. The overall thing is that the 2 hydrogens getting added. That's it. फिर ये वाला infrared spectrum. ठीक है. So you've got a question on infrared spectrum. Remember, I told you that when you look at an infrared spectrum, this is so the focus should be on these 2 functional groups. The OH, sorry, not the functional groups, but the bonds. Infrared spectroscopy, where you will have bonds vibrating at different frequencies. These ones are easy to identify, so you target these first. So if I go over here, there's an absorption at 1700 range. So this one is clearly serial bond O. And this one over here, you've got an absorption in this range as well, around 3000. So what could this be? So is this OH or not? So you'll have a look. As a first thing, the alcohol OH has an absorption that's greater than 3200. So if it's greater than 3200, this one would be. Okay, so alcohol OH, that's going to be greater than 3200. So that's greater than 3200 is जो यहाँ पे paper में ना, that's not greater than 3200. So definitely not an alcohol OH. और क्या हो सकता है? Or it could be carboxylic acid OH, but carboxylic acid OH has a strong and broad absorption. So this one again is definitely not carboxylic acid OH, because that absorption is going to be strong and very broad. So 3000 Kuiper, what could this be? 3000, it must be this one then. The carbon chain hydrogens, that's it. So one thing is clear that this molecule over here, this one over here, I know it's got a serial bond O. That is something I know. And I know that it doesn't have any OH. No carboxylic acid OH, no alcohol OH. None of them are present. So I state how the spectrum differs from an infrared spectrum of glycolic acid. So we just have to find the difference. So glycolic acid is going to have a strong and very broad absorption, at 3000. That is for glycolic acid. the one that's given above, CH2, OH, and COH. Why? Because it's got a carboxylic acid OH. Plus, it's not going to have any serial bond O. So no serial bond O absorption, since it doesn't have it. So no absorption in the 1600, 1700 wave number. Whereas this molecule Y over here will have the opposite. It's not going to have any OH absorption, but it will have a serial bond O absorption. So both of them are different. So we can figure out what is this thing, C4H4 O4. So that's kind of hard to figure out, but if you look carefully, okay, this one over here is hard to figure out, but if you look carefully, there are two molecules of this combining and two water molecules getting removed. So I'm going to make glycolic acid, two of them. So it's CH2, OH, and serial bond OH. That's glycolic acid. I'm going to make two of them. And CH2OH. And remember, it's a condensation reaction. Whenever you have a carboxylic acid and an alcohol in front of each other, they would have a condensation reaction. And they would end up forming water molecules. And they would end up forming ester links. So the OH and H would be lost. And they would end up forming ester links. So that is probably going to be structure Y. And is structure Y fitting this description? It's got no OH, right? And it's got a serial bond O. So it does have a serial bond O. So it fits this description as well. So make sure you should have gotten a hint that it's an alcohol and it's a carboxylic acid and it is reacting with itself. So that means the carboxylic acid part of one molecule is reacting with the alcohol part and they're forming esters. The alcohol part of the other molecule is reacting with the carboxylic acid part of the other molecule and they're forming esters. So it's a cyclic ester that's getting formed in this question. Is clear? Oswald, Sidra, is this clear? Omar, clear? So now, I mean, this paper, we can try and do one more question, which is not organic. Just a second. अच्छा तो और कुछ try कर लेते हैं. Let's say, let's start with the first one. Ajay Singh, give the electronic configuration of Fe2 plus. So I mean that's kind of easy. It's going to be 26 electrons. So it's 1s2, 2s2, 2p6, 3s2, 3p6, and then you have 4s2, and then 3d. That's 20 electrons. So you're left with 26 hote hain iske paas. Now it's 2 plus, so that means this is gone. Then he's saying calculate the oxidation number of sulfur in S2 2 minus. S2 and the charge is 2 minus. So how do you calculate the oxidation number? You take sulfur as X and there are two of them and the total charge is equal to -2. So X would come out to be equal to -1. So the oxidation number of sulfur is -1. Describe the metallic bonding in gold. That's your O-levels question. Okay, it's a regular arrangement of positive metal ions. Of positive metal ions in a sea of free moving delocalized electrons. And you can draw a diagram as well if you like to. That's, I mean, they probably gave you space because of that. Then you have environment, it's an open-ended question. So sulfur dioxide produced during roasting would cause, no, that's not that open-ended because It's going to produce state one of these environmental consequences. So it's going to produce acid rain, and acid rain would make the soil and water bodies become acidic. Next one is you've got complete the equation to show the roasting of iron pyrite in oxygen. So I think they gave you oxygen. Not really. And they told us that if you had, he's saying it's iron pyrite is roasted in oxygen, it produces iron 3 oxide and sulfur dioxide. So there's going to be sulfur dioxide. You can try and balance this. There are 2 sulfurs here, so there's going to be 2 sulfurs, and you can balance the oxygens. That's 4 plus 6, that's 10. So there's going to be 5 O2. Then you have a moles question. A sample of impure iron pyrite was roasted in oxygen. The composition of the mixture solid produced is shown. Calculate the mass of FeS2 present in the sample of impure iron pyrite, assuming that all the FeS2 was converted to Fe2O3 during the roasting process. So first thing, Fe2O3, mass per gram. So this question, TK, just so first thing is, how many moles is that? I'm going to find the moles of this. I mean, they gave us the MR as well. So so moles would be 33.18 divided by, that's not mass, that's in grams, 33.18 divided by what? 120, right? So you've got 120 over here. It's going to be 33.18 divided by, वो कर लेते हैं. So divided by 120, that's 0.765 moles. So we know that the moles of Fe2O3, that's 0.2765 moles. So that means if this is 0.2675 moles, then the moles of FeS2 would be double that. So you're going to double that, and that would give you 0.553 moles. So I've figured out the moles of FeS2. And he was looking for the mass. So we can find the mass. Mass would be moles of 0.553 multiplied by, as I did the whole question incorrectly. Everything is wrong because Fe2O3 is actually, the MR is 159.6. So this should have been 159.6. So let me quickly do the math again. It's going to be 33.18 divided by 159.6. So this one, these moles over here, iske jo hai, that's coming out to be 0.208 moles. And then you double the moles to find FeS2 moles. So that's going to be so that's going to be 0.416 moles. So this over here is 0.416 moles. So moles multiplied by MR, that's the last part, 0.416. And it's going to be multiplied by FeS2, kitna, that's 120. So that would give you 49.9 grams. And then he's saying, use your answer to calculate the percentage by mass of gold in this sample of iron pyrite. Assume that gold is the only impurities in this sample of iron pyrite. Give your answer to 2 significant figures. So agar ye 49.9 grams hai, gold has a mass of 0.37 grams. And we're assuming that gold does not react with the oxygen. So So the gold was initially your iron pyrite had FeS2 49.9 grams. जब उसको burn किया था ना, it had gold in it, and the mass of the gold is given as I mean उसके the table में given as that's 0.37 grams. So you just have to find the percentage by mass. So it's going to be 0.37 is present in the total, which is 49.9 plus 0.37, and you're going to multiply it by 100, so you get a percentage, and that will give you your answer. So your question clear है ये वाला? So the next one is, why is nitrogen inert? Two reasons. You've got an N triple bond N. Why is it inert? Because one thing is it's got a triple bond. Triple bond is hard to break. So the triple bond has high bond energy. Second reason is it's non-polar. So that's one reason. Reason number two, it's non-polar. So it's not going to attract other molecules. Or natural molecular dot and cross diagrams of bani jayega. Explain why N2 and O2 reaction occurs during lightning strikes, because lightning strikes, it provides very high temperatures. So N triple bond N breaks. Write two equations to suggest how the NO form reacts further to create nitric acid. Two equations. NO first gets oxidized to NO2. And that NO2 then reacts with water and some oxygen to produce nitric acid. Two molecules of nitric acid. Or what problem is caused by the uncontrolled use of nitrate fertilizers? So eutrophication, you have to explain all of that. That they end up in rivers and lakes. They promote algae growth, and because of that, sunlight gets blocked, marine plants die, and bacteria grows, and then eventually fish die. Why is calcium hydroxide added to some soils to neutralize it, to neutralize acidic soils? Why would you not add calcium hydroxide, which is lime, to a soil that contains ammonium salts? Because it's going to be an acid-base reaction, and you'll end up with ammonia gas. Because the ammonium ion releases the H+1, the base accepts the H+1. They would end up forming water and NH3. So ammonia gas would escape. Plants need nitrogen. You don't want nitrogen to escape from the soil. Another fertilizer, calcium nitrate, is formed when solid calcium carbonate is added to a mixture of aqueous ammonium nitrate and dilute nitric acid. Suggests what would be observed in this reaction. So first thing, when you add a carbonate to nitric acid, you'll see effervescence, bubbles. Effervescence of CO2. And then so what would we observe? The other part is it's going to get dissolved. Like it will form, calcium carbonate would form calcium nitrate, and then the calcium nitrate and the ammonium nitrate would just mix up. So it's going to be calcium and ammonium nitrate. So it's going to dissolve. That's the other thing, that it will react, it will dissolve. I mean, this calcium carbonate would dissolve. And effervescence of CO2 is going to be produced, carbonate with acid. Calcium nitrate decomposes, so write the equation for decomposition, that it decomposes and produces calcium oxide plus 2NO2 plus half O2. Or vapor pressure is no longer in your course, so I'm not going to do that. But here, let's कंटिन्यू नेक्स्ट टाइम, ठीक है? कल फिर कंटिन्यू करते हैं, पूरा पेपर करेंगे, ठीक है? ओके एवरीवन, टेक केयर।